you have a controller. Okay, so you have a controller. So the controller is connected with some sensors. Okay, so the sensors are there. Okay, so where the sensor is reading some information. Okay, so let's consider like this sensor is reading the information, and the sensor, no, in meantime, it is giving the output to the motor. So here I have a motor. It is keep on rotating. So when the motor, what exactly will happen is, so due to the sensor, okay, so the sensor here, it it reads the information like 0 1 0. Okay, so 1 and 0. So what happens exactly here is there will be off or on condition is happening continuously. Okay, so whenever you this considered like the sensor is reading the information. Now the sensor got a problem, means it is not working. Okay, so it is not working. Now this failure is going now. Means the one means the failure is there, zero means failure is like fluctuation is happening. So whenever it is happening, right, the number of cycles is adding more. Okay, so due to that number of cycles and information is adding, so they will we have the EEPROM memory. Okay, so EEPROM memory and the cache memory. Okay, so cache memory will be there. So whenever there is a data is copying, so it will take the cache memory and from there it will take into the memory. So, and what exactly now will happen is whenever it is carrying the memory uh, data or the files from cache memory to the other part, there will be chances of happening the failures. Okay, means for the failures, whatever the fault or failure is there, no, that failure is repeating continuously. Okay, so that repeating failures will be there. So that repeating failures means first time it will get like 01, 02, 03, 04 like that. Okay, so same failure only, the failure numbers are increasing continuously. Okay, so to clear means I don't want to do this repetition of the failures every time because it is consuming memory. I need to clear this. Okay, so that's what like this clearing diagnostic information came into the picture where it will clear the caches of the memory. Okay, copies and caches of the memory. So what are the important points? So here it's clear the memory from, one second guys, I'm getting called, just 2 minutes. Yeah, sorry. So here what exactly will happen is, so whenever you are sending the data, okay, so the that whether this is for one file, like similarly, the files will be creating every time and it more memory will be occupied more. Like in our mobile, we have a cache files. How we are making clear and making our system more active. Similarly, like to make the system active in the real time also, this 14 service it will do. Okay, so this will make the uh, request and it will clear the those files. Okay, so here the service ID 14 is a designated for the clearance of the current DTC's false code. This is a point you need to write down in the notes. And next is what are the specific things. So the first part will be the server response. So this is the instant point, like a handling of the multiple copies of the DTC status information. See, these 2 points are very important. Others are just, it is a kind of a repeated sentence where I told you. So in instance where the server maintain multiple instance of DTC status. Okay. So as I told, like file 01, file 02, file 03, same file, but it is repeating the numbers. Okay, so such as in the RAM or EEPROM memory, it is mandated to clear the instance. Okay, we need to clear that repeated failures. So that is what this clear DTC will help us. So once this recording will share to you, right, you can write down the 2 points. So this is a 1 point and this is another point. You need to make it note and write in the interview. You need to explain in the interview also. Okay, and before going to this uh, process, I like to add you the one interview for you. Okay, like we have a CAPL. So in the CAPL program, so I have two messages. Okay, Akila Gautam, you are there, right? So I hope you are able to hear me.
Yes,
Yes,
sir.
sir.
So yeah, good. So like we have two messages. Okay, so the first message is should go because it is the managerial question they asked. So message one is sent in 100 milliseconds. So you know how to send the message of M1 100 milliseconds. Now the message two is sent at 200 milliseconds. Okay, and now it is clear, right? Like message two different messages, two different timers.
Yes, sir.
Okay. Next, after 500 seconds, 500 seconds, yeah, 5 seconds, 5000 milliseconds. Okay. This M1 is sent at 200 milliseconds, just is swapping the time. Okay. M2 is sent at 100 milliseconds time. Okay. This is my requirement. You can try to write the program. Okay. So even for others who try to watch the recording video, so those people also can try this. This is one very important interview question. Okay. So you try to solve this assignment. Okay. So moreover, it will be helpful for you in the real time because managers, some of the companies they can ask you. So that time it will be easier for you.
Yes, sir.
Okay, so let's go into the 14 service. So 14 service, this is the service ID and FFF will be the data. So X will be the invalid and Y will be the NRC. So we have a testing tool and the ECG. So my request is the 14FF. So here we don't have any sub function. So this will be a part of the 3 bytes of the sub functions. Means this will be the data. It is a group, okay, diagnostics group information. It has specific information like if you are sending 00001 means you are clearing only one failure. Okay, so if you are sending 00002 means you are clearing the two failures. Okay, so it is like this, but generally remember, like we in interviews or something, so you need to give this. Okay, so if they ask you, like is there any other values that we where we can give 0001 means what will happen, so you need to say that just the one means it will be a clearing of the false, but generally this is a term you should remember. The request, if you are sending 14 FFF and it is a valid request, then you will get a response of 54. Okay, and parallelly, like when you are sending the request of 14 FFF and the X, so means it is like invalid data, right? I am sending the invalid data, so that is the invalid request. So we'll get the negative response. So that is 7F40YY. We'll get the negative response. So that's how these 14 services will help us for clearing of the DTC. Means once you are getting this positive response means here the DTCs, whatever the repeated uh, copies will be there, right? So that will be cleared. Okay, cleared the repeated or copies of DTCs. Okay, so invalid means it not cleared the DTC. Is it clear, right? 14 services is completed. Next, what are the supported NRCs? So the supported NRCs are 13, 22, and 31. Okay, is it clear, right? and 72. Next is coming to the 2F. Okay, so this is very important. Input output control by identifier. Write down input output control by identifier. That is a 2F. So, like, what is the purpose of this input output control is like I have a controller. Okay, so where my output is the motor. Imagine like I have a fan or motor, anything, it's fine. Like fan backend, it will be the motor. Okay, so you are connecting with the canary tool. This is a real-time concept. Okay, so canary tool, and you are communicating with the CAN cable. That's fine. Now everything is clear, but you need to by sending the request, right? Like from the canary tool, even in the garages. Okay, so even the garages, the mission like who is going to repair, okay, is the tester, if you can say. So even with the help of the tool, he is sending the command to the motor, because you need to check specifically the motor or the fan, whether after sending the request is the motor is rotating or not. Okay, so it specifically need to operate. Okay, so if I send the request, okay, a motor rotate for 5 seconds, so the motor will rotate for 5 seconds and it will be turned off. Okay, motor, just freeze it. Okay, don't rotate now, just freeze it. So it will be freezed. So like how we are controlling that input and output, means the input is we are giving and output is the motor is making the appearance. So this is how the input output control. So with the help of identifier, so means with the help of the ID we are doing it. So what is our requirement is, so what is the service ID for this? So we have the service ID of 2F and input output control. So what exactly operation you should perform, whether you need to rotate or you need to turn off, you need to freeze, it will be part of the sub functions. Okay, and what you should go with the ID, because the motor or any solenoids, so it have a specific DADs will be there. So that will be part of the identifiers. So here my DAD means it will be talks about the 2 bytes of data. So here like 2F means D1 and D2, and the sub functions means 0, 1. So when you send this request, okay, so the motor will start immediately, because we sub functions, it have some specific information. Going forward, we'll understand what are the sub functions, what are the specific path it will follow. Okay, so now as the these are like the same, like whatever this service is used by the client to substitute the value for input signal, acts a internal service function and force to control a value of the output. Means we are forcing the motor to control the scenario, like it is directly controlling the actuator signals. Means whatever the motors we say, it is a part of the actuator, so where it will be accessed to the application, so and it we are making to control it. Okay, there are 4 types of control parameters. The first one is return control to ECU. This is a sub function. So okay, return control to ECU means whatever, so the fan, it starts rotated, right? So 5 seconds it starts on rotating and it is stopping again after 5 seconds. So that is a part of a return control to ECU. This parameter returns the control of the actuator to the ECU. So this is a the 0, 1. So 0, 1 is reset to default. Reset to default is the 0, 1. So what this, it will be this parameter reset the actuator to the default state, whether it means it will return to the position, and the position it have a value, right? So whether it is a 0, 0, 0, 1 or 0, 2. So that if I mention like my default value is 0, 3 0, 2 always. So whenever the motor stops at 0, 2 value only, that is a kind of a reset to default. And next is a freeze state. So freeze state is you are giving some force to the motor, but it is stopping at the same time. It's not moving. It is a part of the freezed current state. And short-term adjustment, so just you are adjusting the some behavior. Means okay, a motor rotates slowly. Okay, you need to rotate at a speed of 5 5 kmph, or 3 kmph. So you make some rotations of 50 meters. Like that, we are specifically adjusting, giving some value and making the motor to rotate. So these are the 4 sub functions. So it's very important, I can say. Whenever you need to mention some of the projects, it's specific to the actuators of the move fans or motors. You can take this as an example and you can explain to the interviewer. Okay, so that may get a good confidence, because only few of the real-time candidates can work on these services. Okay, now coming to the other part, like what is my request and what is my response? So from the testing tool, like we are sending the request of 2F and the DAD. So the DAD is F1, F2 and 00. So whatever the sub functions we have, so like I'm mentioning like a 00 is my sub function. So I'm getting a positive response. So after the positive response, it will be like 6F. F1 and F2. It is like similarly like 2E. So instead of 2EF, 2E, just we are making like a 2E, and the DAD it have, and it have the data. Okay, but it is not a data, it is like a sub function. Okay, remember this, with the help of the sub function, we are adjusting it. Okay, so in 2E we have this data, but in 2F it is a sub function. Okay, just for your remembrance, I am explaining you. Okay, 6F and F1 and F2. And again, if it is an invalid request, so I'm saying if adding any other bytes of data here, we'll get the negative response. Okay, so it is like the same process. Next is what are the sub functions it have. So return control to the ECU, that is a 00. So what it will give, so it is used to give a feedback control of the actuator or the function to the ECU. So this is a return control to the issue, and mostly it is used for the temporarily it will work. It is not a permanent, so just it is a temporarily it will act. Okay, is it able to hear you right? It's clear.
Yes, sir.
Yes, sir.
Yeah. Next is coming to the, because these are some points where you need to learn. There is no other option. You need to learn and you need to understand and learn, and just do multiple revisions. Okay, so that may help you. So but before doing what exactly this term is, you should remember. Okay, so but with the help of the heading only you can come to know. Okay, written control to ECU means something we are giving the control input and it will to the ECU. Okay, what is the value and how we are controlling to the ECU is that heading only, it will help you to understand. And similarly, like reset to the default. Okay, we are resetting the ECU to the default state. Okay, so this parameter resets the actuators and functions to the default settings. So just you need to remember this concept. And it is used when the system needed to brought to the baseline state. Okay, just it is added information for you. So you can consider this as a 1 point, and this is a 1 point. In your notes, you can write it. And next is a freeze current state. Okay, so here the freeze current state is it freezes the first point you need to write in the notes. This parameter freezes the actuator or functions in the current state. Okay, so freezing the state can help the isolate the issues by preventing further changes during the analysis. So just for your info, and where it hold the system stands steady. So for troubleshooting, just I added the info for you to understand. And short-term adjustment, it is like a 03. So like we are temporarily adjusting the values. Okay, so for the actuators or functions. So that's how it will be. Like these are the 4 sub functions we have. Okay, so whatever I underline, so these are important for the sub functions you to remember. Okay, is it clear, right? So example for 2A, I consider one real-time scenario, air inlet door position, and one DID. Means this DID is specifically for inlet door position. Okay, what we are doing, how we are reading. So step 1 is we are reading the current position of the door. Okay, so and next step is like we are adjusting some value. So if it is like 0, 1, we are adjusting to 0, 2, and so the server has sent a immediate positive response, which includes the like a value of 12%. Okay. So now 12% to I change it to 15%, means I adjusted the value to 12 to 15%. Okay. So next is again where the client has sent a request of reading that information. So it met some value. Okay. So steadily, and for then it will be returning to the ECU step 4, and step 5 is the phrasing state. Okay, so just go through this example slide, it may help you to further. And next is a 2F supported NRC. So 12 function not supported, incorrect message length, condition not correct, and request out of range. And